nail may look like the simplest thing in the world, but a common construction nail can actually support more than 45 kilograms. That's up to 23,000 times its own weight. They can be pounded with an ordinary hammer or shot with a nail gun to join together the wooden frame of a building. But how do they get all that strength into a simple piece of metal? To make the nails as strong as possible, each one is made from a single piece of carbon steel, which arrives in large coils. These have to be cleaned in a hot bath to remove rust before it's cut into individual pieces for the nails. Carbon steel is just what it sounds like. Steel mixed with carbon to make it both harder and stronger. It's strong but quick to rust, so the steel is dunked in a vat of hot sulfuric acid. This eats away the rust without damaging the steel. Once it's clean, just one of these 2,360 kilo coils can make almost 1 million nails. But at 5 millimeters thick, the raw stock is more than twice as thick as the finished nails. To get it to the right thickness, the entire coil is pulled through a wire drawing machine. The machine has 6 steel blocks, each with a small hole in the center. A motor pulls the steel through the holes with almost 1,450 kilograms of force. Each hole is a little smaller than the last. The pressure from the machine forces the wire to elongate in order to fit through the holes. This is done until it's drawn out to a thickness of just 2.3 millimeters, the right diameter for the nails. The finished steel shoots out of the machine at a rate of 10 meters per second and is wound up on giant spools. By the time this spool is full, it'll hold almost 10 kilometers of steel. That's enough to make 40,000 nails. Once a spool is full, the steel uncoils into a machine that makes the nails head first. It happens so fast, the machine is able to make 700 nails per minute. We ask them to slow down the machine so you can see the nails taking shape. First, a die smashes the end of the steel to pound it into the nail head. Once the head is shaped, the machine then pushes out exactly 63.5 millimeters of steel, the length of one nail. 2 carbide cutters then snip it off into a diamond-shaped tip to complete the nail. The diamond tip is designed to be hammered into wood without causing cracks or splinters. The nails come out of the machine ready to take a pounding with a hammer or nail gun. However, it takes another machine to add the one key element that helps these nails grip onto the wood to hold wooden structures together. A threading machine cuts threads into the shaft of the nails, just like the threads you see on the shaft of a screw. The threads are actually able to bite into the fibers of the wood so the nail stays in place. But the nails won't last if the steel rusts. To protect them, the nails head off to be coated in molten zinc. Unlike steel, zinc doesn't rust when it comes into contact with oxygen. Instead, it oxidizes into a protective barrier that prevents the steel from rusting. The process is called hot dip galvanizing. As the nails are dunked, the zinc actually penetrates the steel to form 4 layers of protection. The innermost layer is mostly steel. The outer layer, which comes into direct contact with the air and oxygen, is all zinc. A non-galvanized nail could rust in as little as 6 months. But these galvanized nails should last at least 50 years. Once the zinc is set, the nails are ready for the hammer. But these nails go one better. They're lined up to be coiled into strips for nail guns. A strip of pre-grooved polyethylene plastic is pressed against the nails, which forces the nails into the grooves. The loaded strips pass a counting wheel, which counts out 200 nails, and then it cuts the strips and coils them up. Finally, a magnetic robot arm carries the coil off for packaging. Once in a nail gun, all it takes is a quick shot and these nails will hold for half a century or more.